Hello and welcome everybody on this very special Wednesday, because today we have our release webinar. I hope you're all doing fine and hear everything regarding our new features of MERLIC 5.4. My name is Marcus and I'm part of MVTec's marketing team and very happy to guide you today through this webinar. But before we start, I have some organizational information for you. After the webinar, we will have a Q&A session. Therefore, simply write your questions in the GoToWebinar chat. Also, in a few days after the webinar, you will receive a follow-up mailing with a handout and, of course, the recording. And also, I would like to encourage you to get in touch with our experts after the webinar to ask even more questions and simply talk to them. Talking about our experts, I'm happy to introduce you your speakers of today. Ulf, Xin, please join me here on stage.
Hello, Marcus.
Hey guys.
Hello, Marcus.
And yeah, since this is your first MERLIC webinar, I would like to ask you to introduce yourself quickly to our audience.
Thank you. Yes, my name is Ulf and I'm the new product manager of MERLIC. I started at MVTec 3 months ago and I'm very excited to show you the new features of this new version.
Thanks, Wolf. Hello, everyone. My name is Xin. I'm an application engineer in MVTec. And today I'm also very excited to show you the MERLIC new feature.
All right, guys, I think everything is set for a good webinar. You are excited? You ready?
Sure.
Powerful? And then
Let's go.
Let's go. That's the spirit.
So, welcome to our webinar. In this session, you will learn what's new in MERLIC 5.4 and Xin will give you practical insights with live demonstrations. If you have questions, please use the chat function of the webinar software. But before we talk about new features, let's have a quick look at all the advantages MERLIC offers you when you're looking for an easy-to-use machine vision solution. First of all, why MERLIC? MERLIC covers all your requirements for a vision software. It is easy to use and there are no programming skills required. It is an all-in-one application because it provides all relevant parts for solving the whole application in one software. It is fast in setup. Due to shorter product life cycles, you need to be faster in setting up your vision applications. And it is very flexible because it is equipped with different tools, interfaces, and it supports different kind of hardware. So let's have a quick look at the interface of the MERLIC Creator, the command center of the software. In the upper left area, you can see the tool flow. You just drag and drop different tools from the tool library located directly above. In the tool library, you can find the different vision tasks sorted by application area, for example, alignment, pre-processing, processing, post-processing, as well as logic and deep learning tools. In the central area, you can see the current camera image being processed. To the right of it, there is a tool quick info where useful tips and tricks are displayed. For example, how to use the selected tool in the best possible way, as well as other information. Here you can see the workflow and how it is represented in MERLIC. First of all, use the Integrated Image Source Manager, ISM, for configuring cameras, other image sources or image files, including regions of interest, exposure time, trigger mode, and so on. Now you can create your machine vision application, MVApp, within MERLIC Creator. Here you define the tools and logics. Continue with the front-end designer for statistics, showing values in different user levels. Design your interface for the user of the machine. Show it locally or remotely. And then integrate MERLIC into your process with a runtime environment, RTE. In the RTE setup, you can create and choose recipes, interfaces, and communication protocol. As a last step, start a runtime environment to execute the MV app front-end communicator in processing mode. Here you can see the deep learning methods MERLIC offers. They serve to classify images, detect anomalies in the global context, find objects, deep OCR, and segment image pixel precise. In addition to the deep learning methods, MERLIC brings different industrial proven rule-based processing tools like checking. This is for check presence of connector pins or something else. Reading, read text and numbers or even barcodes and 2D codes. Position determination, check the position of find objects to pick or ensure the product quality. Counting, count holes, cutouts or objects on the conveyor belt. Measuring, you can measure distances, angles, diameters, etc. And defect detection. With a combination of newest AI and proven rule-based tools, you can solve a majority of industrial applications in a robust and efficient way. For more information or a demo version of the current version, please check our website merlic.com. And now let's start with the new features of MERLIC 5.4. The first new feature we introduce is the REST plugin. This interface opens the door to the world of web services. Here you can see the full name of REST, Representational State Transfer. This is a standard API for web services, and it enables the communication of different devices over HTTP. Now you can control MERLIC via a web browser using the built-in web application. This application displays a clear state machine and gives you access to the results easily. Also, there is an API documentation included, which offers you more flexibility to control MERLIC with other interfaces and devices. Now I hand over to Xin to show us this new feature.
Thanks, Wolf. So in the hands-on part, we will introduce you how to use this REST plugin basically. After that, we will also introduce you the API documentation. With the API documentation, we can control MERLIC with another language interfaces. Now, I will close my PowerPoint and start MERLIC. I hope now you can see my software manager. And maybe we will introduce you the difference between MERLIC 5.3 and MERLIC 5.4. If you see the MERLIC 5.3, you will see 4 different ways to open MERLIC. We can click here to open MERLIC Creator, click here to open MERLIC RTE setup, runtime environment setup, or front end, or the combination. But for MERLIC 5.4, we added 2 new possibilities. The first one is we can directly launch the MERLIC communicator. And the second possibility is also very practical. If you need support from us and you would like to send us some log files, you can directly launch here. And some log files will be generated automatically. Now, let's go to the MERLIC RTE setup. And I will connect the local system. And the first step is we will import some recipes, because now we are in the process integration mode and we work with the 4 important components of process integration: recipe management, state machine, result configurations, and some other configurations. If I click here, import recipe, we will see 5 recipes in our standard example. Let's import the last 2. And then we will go to communication and start MERLIC communicator. If we click add plugin instance, we will see a list of plugins that we support in MERLIC. And one new plugin is REST plugin. If I click here, you will see the information of REST plugin on the left-hand side with status, ID, and the name. On the right-hand side, you will see the predefined plugin parameters and also user parameters. We can set IP address and port and determine if we will use the built-in web app. And we can also configure the memory database of the store capacity of events, results, and arrows. Now, let's keep the default parameter and see what happens. I start plugin, and we will see the information here. We have a warning, vision system unavailable. So the next step would be we will open the vision system. We click Start MERLIC RTE, and we will see a front end with nothing. But no worries, we will control MERLIC with web browser with the REST plugin. I can type localhost or the IP address. The port is 8040, and if I click enter, you will see a very clear state machine. So I will separate my screen so that you can see I can control MERLIC via the state machine. In the state machine, you will see different states because in the automation, we assume that a vision system moves from one state to another state with different actions, such as now in the dark blue, you will see our vision system is currently in the state initialized. And the shallow blue means we can use action to go to another state. If we prepare recipe, and the state will change from initialized to ready. So now I click ready, and the window is popped out because we imported 2 recipes. Let's switch the first one, and the first recipe or the first front end is activated, and we will see an image and the relative informations. Now let's click single execution. The other image is processed. Click it again, another image is processed. Now we can go to the result to have a look at what are saved in the result window. We can see the result ID and job ID, and also the output of the vision system, which is the result of the barcodes. Now let's go back to the states, and we would like to switch to another vision system. We click ready and switch another recipe file. You will see another front end is activated with new images and new text. Let's click single execution again 5 times. 1, 2, 3, 4, 5. And we will see 5 results in the results handle. 1, 2, 3, 4, 5 with the result ID, job ID, and the relevant results. Now, as I mentioned just now, we will introduce the API documentation. We implemented also the communicator REST plugin API documentation. If we scroll down, you will see two colors. The blue means we can get the information from the vision system. And green means we can post some information to the vision system. Let's give you an example. If I click here, and we can try it out by execute some configurations by ourselves. And now, for this vision system, it's not very relevant to set the parameters. And the recipe ID was 1. I click execute. Nothing happened. It's weird. Let's have a check of the debug queuing action. Because we forgot a comma. So you will see if we click execute, and the other image is processed. And now let's control MERLIC with another language interface. We implemented a script in Python, and we gave the API URL information with IP address and the port number, and we can copy the action from the API documentation, as you can see here. After that, we will post the information to the vision system. And we used the first recipe. Let's execute the Python script, and you will see another image is processed. And because we also use the get function of the request library, so we can also see the information of state, single execution, prepared recipe, the first, and the corresponding running job. That was the demonstration of REST plugin. Now I will open the PowerPoint again to show you another possibility to use this REST plugin. I hope now you can see my PowerPoint. Another possibility is we can also control MERLIC with another device, which means we have the first device laptop, and we open MERLIC, start a state machine, and in the first laptop, we open MERLIC, and in the second device, we start a state machine, and we can click the state machine, control the MERLIC. That was everything of the REST plugin.
Thank you. Thank you, Xin. There are new awesome possibilities. The presenter doesn't work. Now. The next exciting new feature is called Acquisition Sequences. This feature introduces new possibilities for image acquisition. On the left, 2 different exposure times are used for 2 image acquisitions. In this way, we can realize high dynamic range very easily. On the right-hand side, you can see this feature also allows the combination and synchronization of cameras and non-streaming devices. This is how we can get images under different illuminations to realize photometric stereo. In summary, with this new feature, we can configure more complex setups, more industrial use cases can be covered. This new feature is a concept feature. Currently, you can control the workflow with a JSON file. But the good news is that the roadmap for this feature is already planned. The next step is to provide a graphical user interface, so streaming and non-streaming devices can be configured easily and efficiently. All the parameters can be set via the front end. And most important, your feedback counts. If you have any request regarding this feature, please let us know. So Xin, showtime.
Thanks, Wolf, for introducing the roadmap. As an engineer, I also think it's quite difficult to configure the JSON files. As you can see just now, I forgot the comma, and the vision system just did not work. So now let's introduce you the hands-on part of acquisition sequences. At first, we will introduce you some basic concept of acquisition sequences, and we will show you a live demonstration with our hardware setup of the application high dynamic range. After that, we will also introduce you the possibility to use acquisition sequences to realize the synchronization of multiple devices. Now let's close the PowerPoint again and start MERLIC. We close the application from the first demonstration and open MERLIC Creator. I hope now you can see my MERLIC Creator. So the first thing of the demonstration is we have to connect the camera with MERLIC. We click New Configuration and give the configuration name. Activate the configuration and add new image source. And let's find if the camera is available. That's it. Create new image source. Start live image. And now you will see if I set the exposure time like this, we can only see one part of the object to be inspected. We can only see the small lights. And let's increase exposure time. We will see more things until we can inspect another part of the object. So please keep into this application in your mind, and we will introduce you the basic concept of acquisition sequences. After that, we will go back to MERLIC and realize this application. So we did show you that we require actually 2 images for the application. The first image with lower exporter time and the second image with higher exporter time. And now we will show you how to use the acquisition sequence feature to realize this use case very easily. The first concept we will introduce to you is the sequence lane. Each sequence lane refers to an image source, and we can define different actions on the image source. The available actions are set parameter. We can set different camera parameters in the sequence lane, such as exporter time, gain, etc. And the second parameters are acquire image, which is the most important action among the 4, because without image processing. The second action is delay. We can set a delay between 2 other sections to get some time. And the fourth action is barrier. We can use barrier to achieve the synchronization of multiple devices. Let's show you a simple example, and then we will show you the live demonstration. After that, we will explain the concept barrier again in detail. One simple example is, like just now, set exporter time, set a lower exporter time, acquire an image, set a higher exporter time, and acquire another image. Now let's achieve the high dynamic range with MERLIC. So let's go back to the configuration. We did configure the camera, so we will see the camera configurations in the configurations folder. And we also need acquisition sequence files. And we prepared for you here. Let's copy them to the configurations at first, and let's have a look at the 2 files. The first file is sequence HDR. In this file, you will see the version, the first 0.0, because it's the first version of the new feature. And you will see the lanes. On this lane, we can define device type, device ID, and the corresponding actions. The actions are set exporter time, acquire 1 image, set exporter time, and acquire another image. Besides, we will also introduce you the other very simple JSON file. In this JSON file, with the end string meta_seq, we can define a sequence file to set it as default, so that if we open the image source manager, this sequence file will be loaded automatically. So if you can see here, we added the acquisition sequence files and also set the meta_seq file. Therefore, you will see the sequence HDR is in the status active, and it is set by default. You can also see above there is a base sequence. Base sequence mimic the basic behavior of image source manager of the previous MERLIC version, which means if we set it as active, we can only see one image with the name of image source manager, and we can only acquire one image. But if we activate another sequence file as active, we can set two images, image 1 with one exposure time and image 2 with another exposure time. We also prepared a MV app to give you a clear front-end design. Let's open that. LED inspection, front-end design, launch the front end. If I click single execution, you will see the left image is an image with lower exposure time. We can only see the small LED lights, and the right image is an image with higher exposure time. We can see the whole very clearly. And if we combine the two images with the high dynamic range technique, we can observe the two features clearly. That was the HDR example. It's quite easy with acquisition sequence feature, right? So let's go back to the PowerPoint and see some other possibilities. Now, I think you can see my PowerPoint again. Very good. As I promised just now, we will explain how to work with barrier. Let's assume another use case. In this use case, we require not only one camera, but also the lightning. So we would like to control the lightning turning on and off. And in between, we would like to acquire an image. So we need two lanes. The first lane refers to the light, and we can define actions turn on and turn off. The second lane refers to the camera, and we can define an action which is acquire image. But you will realize the problem. If we define our lanes like this, we cannot synchronize them. Therefore, we introduced the barrier concept to do the synchronization. The lanes of different image sources are executed in parallel. And when the execution of a lane arrives at a barrier, it waits until all other lanes have also arrived at their according barrier. So with the barrier, we can set a very concrete acquisition sequence files. So if we add one elimination, we can make use of different eliminations to have more information of the to be inspected object. And we can also use non-streaming device to control the lightning. So this is another use case. We can acquire an image with lightning 1 and acquire another image with the lightning 2. And this is a simplified acquisition sequence file. We can define two lanes with the corresponding image sources and actions.
Thank you, Xin. I have another point to mention in this regard. If you are interested in this feature, we provide a special documentation for you. This documentation can be requested via our support portal or via the sales partners. The next feature I want to show you is the Schneider electric PLC with MODICON plugin. This broadens the range of applications that can be easily integrated with MERLIC. For instance, the integration would enable robots and MERLIC to collaborate directly using a MODICON PLC. You are able to control and monitor the vision system in the process integration mode. Transmit commands, results, and further information by both the plugin and the PLC. Xin, please show us this feature.
Of course. So in the next hands-on part, we will show you how to configure the MODICON plugin. Similar to REST plugin, we can start communicator in the communication. And we add the MODICON plugin by clicking Add Plugin Instance. You will see the user parameters in 5 different categories: Ethernet connection details, result handling behavior, writing data to PLC memory, reading data from PLC memory, and export symbols. In the following slides, we will introduce you each category in detail. Regarding the Ethernet connection details, we can set the IP address and the port number of the MODICON plugin that we want to connect. And for the result handling behavior, we define settings with respect to the retrieval of the results. The MODICON plugin offers 2 different types of results modes: free running or dequeue from buffer. If you use the dequeue from buffer mode, you should also set the following 2 parameters. The next parameter is writing data to PLC memory. These parameters can be used to allocate the required memory for the results that shall be transmitted to the PLC. For this example, if our result of the MV app consists of 1 boolean, 2 integer, and 1 string, we should configure the writing data to PLC memory like this, so that we can allocate the right memories for our results. Similarly, sometimes we should also allocate the memories for our input values. We can configure it like this. For this input value, we require 2 integers and strings among all the recipe files. So what's the advantage if we configure the input values? In this way, we can overwrite the input values without changing recipes. Last but not least, the export symbols. The PLC wants to know the configuration that we did in MERLIC. Therefore, this click on Start Plugin will generate a CSV file. And the CSV file will contain all the control variables, input, results that are needed to connect MERLIC and also the recipes. After doing all the configurations, the connection between MERLIC and the Schneider Electric MODICON PLC is configured in EcoStruxure Machine Expert, which is a PLC engineering software of Schneider Electric. That was the MODICON plugin, and Ulf will introduce you the further improvements.
Thank you, Xin, for showing us the new connectivity possibilities. We'll see you later in the questions and answers section. Thank you.
See you later.
Now let's come to further improvements we have implemented in version 5.4. For the start, we enhanced the usability in the MERLIC RTE setup. It is possible now to save acquired images directly to file. Those files can be used for training of a deep learning model, for instance. In addition to this, there is improved zooming functionality. The functionality of the MERLIC plugin has been expanded. MERLIC 5.4 now enables the generation of label files for import in GXWork3 in addition to GXWork2. So we can offer the full support of the IQF and the IQR series. In addition to this, the English and Japanese locale is provided. There is a new tool parameter called detection model files. It allows the user to select which of the provided detection models shall be used. That is, which deep OCR model component shall be used for the word detection. Currently, 2 pre-trained detection models can be selected. However, you can also use your own detection model. With the new version 5.4, it is possible now to configure image sources directly from the image source tool. This will speed up your workflow. With the next improvement, we provide a better overview of the parameter values. If you move your mouse over the parameters, the values are displayed. For tuples, even the number of tuple elements, as well as the minimum and maximum values are shown. In MERLIC Creator, Chinese and Japanese texts in vertical directions are now written from top to bottom. We have added a keyboard navigation in the tool library, so you can switch the tools easily with your keyboard. And you can now add new tools directly from the tool flow context menu. This will also speed up the process of building your MV apps. In addition, MERLIC comes with some new options for multiple MERLIC installations. The new version of the software manager, which is known as SOM, always allows you to register a MERLIC installation. If you installed multiple MERLIC versions, you can register the desired installation to associate your MERLIC files, such as MV apps, to the respective version. This concludes our new feature presentation. And now let's change to a tips and tricks section. First of all, let's have a look at the Image Source Manager to acquire images. MERLIC supports the standardized image sources: GigiVision, GeniCam, USB 3 Vision, and read from file. In MERLIC, there are 2 ways to acquire images. The classical way, with the acquire image function, and the recommended way, using the Image Source Manager in the runtime environment setup, known as RTE setup. The advantage of using the Image Source Manager is that you separate the image source configuration from the tool workflow in your MV app. You can develop your MV app independent from the image source, and you can change the image source without editing the MV app. All camera parameters are stored persistent, and if you restart your system, the camera is using the same settings. Another tip: to check what's new in the current version, you can find a special What's New section in the documentation. Here is an overview of the most important new features. The context-sensitive help is very comfortable. With a keyboard shortcut F1, the documentation will open at the point that describes the element that is currently in focus. And in the Help menu, you can find an entry Submit Feedback. This is your direct way to me and our team. I look forward to your feedback and will be happy to assist you. What else do we offer? Please check out our website for additional services. One of them is the MVTec Academy, which is a digital learning platform that provides interactive online courses on MVTec products. We are planning to release MERLIC content in 2024. Other services are free application evaluation, feasibility studies, customer-specific projects, trainings and workshops, videos and tutorials. If you have questions regarding this service, we are happy to help. So this concludes our tips and tricks section. Thank you. And as I have already mentioned, if you have any questions, please use the chat function of the webinar software. And now we come to a little survey. We have a break, and please answer the questions we have prepared for you. Thank you.